Are you preparing for a Selenium Automation Testing interview? In this video, we've compiled the top 10 most commonly asked Selenium interview questions, along with detailed, beginner-friendly explanations. Whether you're a fresher or an experienced tester brushing up before your next round, this guide will help you answer confidently and clearly. So let's get started with the first question. Selenium is one of the most popular open-source frameworks used for automating web application testing across different browsers and platforms. It does not support desktop or mobile application testing directly, but when it comes to web automation, Selenium is considered a standard tool in the industry. The Selenium suite is made up of several components, each serving a unique purpose in the automation process. Let's walk through them. First, we have Selenium IDE, which stands for Integrated Development Environment. It's a Firefox and Chrome extension that provides a simple record and playback feature, primarily used by beginners or for quickly generating test scripts. Second, the most widely used component is Selenium WebDriver. This is where the real power of Selenium lies. WebDriver allows us to write automation scripts in various programming languages such as Java, Python, C#, Ruby, and more. It directly communicates with the browser to simulate user actions like clicking, typing, scrolling, and navigation. Third, we have Selenium Grid, which is used for running tests on multiple machines and browsers simultaneously. This enables parallel test execution, saving time and ensuring broader test coverage. Lastly, it's worth mentioning Selenium Remote Control, or Selenium RC, which was the original version used before WebDriver. It's now deprecated and replaced by the more efficient WebDriver API. To summarize, Selenium is not just a single tool, but a suite of powerful tools that together provide flexibility, scalability, and ease of automation for any web-based application. In this question, we're comparing Selenium 3 and the latest version, Selenium 4, a topic that interviewers often ask to assess how updated you are with the tool. Let's begin with the main architectural change. Selenium 4 is fully W3 WebDriver compliant. In simple terms, this means Selenium WebDriver now communicates directly with modern browsers using the standardized W3C protocol. In Selenium 3, the WebDriver API was only partially W3S compliant, so it had to translate requests, causing extra overhead and some inconsistencies in behavior across browsers. With Selenium 4, this layer of translation is eliminated, resulting in faster and more stable test execution. Next, a very handy feature added in Selenium 4 is relative locators. These allow you to locate elements based on their position relative to other elements. For example, you can now say, "Find the button to the right of the input field." This wasn't possible with earlier versions and makes test scripts more readable and maintainable. Selenium 4 also introduces a refreshed UI for Selenium Grid, with built-in support for Docker and distributed test execution. The new grid is easier to set up and offers better scalability and monitoring, which is great for teams running tests in parallel or across environments. Another enhancement is the integration of Chrome DevTools Protocol, CDP. Selenium 4 now allows direct access to the browser's internals, enabling capabilities like capturing performance metrics, network logs, geolocation mocking, and much more, all within your test scripts. One more subtle but important improvement is that the wait and timeout strategies in Selenium 4 have been made more consistent across different languages and drivers, improving reliability across test cases. Lastly, although the Java IP has some slight syntax changes and deprecations, migrating from Selenium 3 to Selenium 4 is quite smooth overall. So, in summary, Selenium 4 uses a more stable W3ASIC compliant protocol. It adds powerful new features like relative locators and DevTools support. And it modernizes Selenium Grid for better test distribution. These upgrades make Selenium 4 more robust, developer-friendly, and future-ready compared to Selenium 3. Locating web elements accurately is one of the most fundamental skills in Selenium automation. If your locators are unreliable or fragile, your entire test script can break, no matter how well you write the rest of the code. In Selenium, we use something called locator strategies to identify and interact with elements on a web page. Selenium WebDriver offers 8 primary types of locators. This is the fastest and most preferred locator. If an element has a unique ID, always use it. For example, driver fundelemp by id username. Name. If ID is not available and the element has a unique name attribute, you can use driver fundelemp by name. Class name. Use this when elements share a common CSS class. However, this works best only when the class is unique to the element you're targeting. Example, driver fundelement by class name. Tag name. This locator is rarely used alone, but it helps when you want to find elements like all tags or all tags. T-link text and partial link text. These are helpful when dealing with hyperlinks. For example, by link text forgot password, or by partial link text forgot. Key XPath. XPath is a powerful locator strategy that allows you to traverse the HTML DOM and locate elements precisely. It supports both absolute and relative path. Example, driver fundelemp by XPath input at tape at text. Key, CSS Selector. This is another powerful and often preferred method. It's faster than XPath in most browsers and less prone to breakage if used properly. Example, driver fundelemp by CSS Selector, input type text. Each strategy has its pros and cons, so the best practice is to always choose the most specific and least brittle locator available. Also, avoid relying on auto-generated attributes like dynamic IDs or indexes, as they may change frequently and cause flaky tests. For real-world automation, you'll often end up combining locators or even building custom XPath expressions based on attributes, text, or element hierarchy. In summary, Selenium gives you the flexibility to locate elements in multiple ways, but your goal should always be to have fast, stable, and reusable locators. This is a very common question in Selenium interviews, especially when the interviewer wants to test your understanding of how web elements are identified in dynamic and complex applications. Let's first understand what XPath and CSS selectors are. XPath is a language used for navigating through elements and attributes in an XML document. Since HTML is also a type of XML, XPath can be used to locate web elements precisely based on their structure, attributes, or even text content. On the other hand, CSS selectors are patterns used to select HTML elements based on their ID, class, type, attributes, and hierarchical relationships, the same way we use them in styling with CSS. Now let's compare them based on key features. 1. Syntax simplicity. CSS selectors generally have a cleaner and shorter syntax compared to XPath. For example, XPath, input at email. CSS, input #email. So, for simple selectors, CSS is easier to write and understand. 2. Performance. In terms of speed, CSS selectors are usually faster than XPath in most browsers, especially in Chrome. XPath tends to be a bit slower due to the way it navigates the DOM. 3. Traversing the DOM. This is where XPath shines. It supports both forward and backward navigation in the DOM tree. That means you can locate an element based on its parent or even a preceding sibling. CSS selectors can only move forward, from parent to child, not the other way around. 4. Text-based selection. Only XPath allows you to locate elements based on their text content. For example, button text, login. This is not possible using CSS selectors. 5. Browser compatibility. 1. CSS selectors are more consistent across different browsers. Some older versions of Internet Explorer had issues executing complex XPath queries, though this is less of a concern today. 6. Use in Selenium. Both XPath and CSS Selectors are widely used in Selenium. However, best practice is to use ID or name locators if available. If not, use CSS for speed and simplicity, or XPath when complex relationships or text conditions are needed. So which is better? It depends on the use case. Use CSS selectors when you want performance and simplicity. Use XPath when you need flexibility, like navigating the DOM in both directions or selecting elements by text. In real-world projects, you'll often use a combination of both, based on the structure of the web application under test. This question may seem simple at first glance, but it's a favorite in interviews to test how well you understand WebDriver navigation behind the scene. Both driver.get are used to open a web page in the browser, but there are subtle differences in behavior and flexibility between the two methods. Let's break it down. 1. Purpose and usage. Driver.get URL is a straightforward method that loads a web page and waits for the page to completely load. It's the most commonly used method when you just want to open a URL. On the other hand, driver.navigate URL does the same thing, but it comes from the navigate interface, which also supports additional browser navigation actions like back, forward, and refresh. So if you're just loading a page, either will work. But navigate is preferred when you're building flows that involve multiple browser actions. Behind the scenes. Driver.get is like telling the browser, go to this URL and wait until it's fully loaded, whereas navigate is conceptually like, move the browser to a new page. It behaves more like browser navigation rather than just opening a page. 3. Flexibility. Because navigate is part of the navigation interface, it gives access to powerful commands like navigate back, go back to the previous page. Navigate forward, move forward in browser history. Navigate refresh the current page. Driver.get does not support these additional commands. Use in page object models or frameworks. In large frameworks, or when using page object models, navigate is sometimes preferred for page transitions, while get is often used for initial test setups or landing on a base URL. 5. Performance differences. There is no significant performance difference between the two in most use cases. However, driver.get may sometimes wait a bit longer for the page to load fully compared to navigate. Depending on the browser and network behavior. 6. Practical example. Driver.get HTTPs, example.com. Simple, clear, and used for direct page load. Driver.navigate. HTTP, example.com. More versatile, especially if followed by navigate, back, or refresh. Summarize. Use driver.get. Use driver.navigate. When you're combining it with other navigation actions or need more control over browser history. Both are correct, but knowing when and why to use each demonstrates a deeper understanding of Selenium WebDriver. In automation testing with Selenium, one of the most common causes of test failures is timing issues, when the script tries to interact with a web element before it's available in the DOM or fully rendered on the screen. To solve this, Selenium provides different types of wait mechanisms that allow the test execution to pause or retry until the required condition is met. There are mainly 3 types of waits in Selenium. Implicit wait. Explicit wait. Fluent wait. Let's look at each in detail. 1. Implicit wait. An implicit wait is applied globally to the WebDriver instance. It tells Selenium to wait for a certain amount of time while trying to locate elements before throwing a no-socialment exception. Once set, it applies to all elements in the script. Example, Java code. Driver.manage. Timeouts. Implicitly wait 10 seconds. This means wait up to 10 seconds for elements to appear before failing. It's simple to use but not always flexible, especially when different elements require different wait conditions. 2. Explicit wait. Explicit wait is more powerful and targeted. It allows us to wait for a specific condition to occur for a specific element, using WebDriver wait along with expected conditions. You can wait for conditions like element to be clickable, element to be visible, title to contain a keyword. This gives you more control over waiting logic. Example, Java code. WebDriver wait, OK, new WebDriver wait. Driver 10. Wait until expected conditions, visibility of element located. By IED submit. Here, Selenium waits up to 10 seconds for the submit button to become visible before proceeding. 3. Fluent wait. Fluent wait is an advanced form of explicit wait. It lets you define total timeout, polling frequency, how often to check, what exceptions to ignore. This is especially useful when you're dealing with dynamic elements that load irregularly or with AJAX calls. Example, Java code. Wait, fluent wait, new, fluent waity, driver. Gurney. With time it, duration, of seconds. Adding. Polling every, duration. Ignoring, Nasushament exception class. Fluent wait, until, expected conditions, das elemento, be clickable, by IID start. This setup checks every 2 seconds, up to 15 seconds, and ignores any no sushlement exception during that time. Bonus tip, thread, sleep. While technically not a Selenium wait, some people use thread, sleep, to pause execution. This is not recommended, as it causes unnecessary delay, and doesn't check for conditions dynamically. Use Selenium waits instead, they are smarter and more efficient. Key, to summarize. Use implicit wait when you need a basic, global timeout. Use explicit wait when you want to wait for a specific condition. Use fluent wait when you need advanced retry logic and polling control. Mastering waits is crucial to writing stable, reliable automation scripts, especially for modern, asynchronous web apps. Dropdowns are a common element in web applications, used for selecting countries, roles, categories, and more. In Selenium, handling dropdowns is very straightforward when they're built using the standard HTML tag. Selenium provides a special class called Select, which is part of the org openkia.selenium.dos to package. package. This class contains various methods to interact with dropdowns and select or deselect options based on index, visible text, or value. Let's go through the steps. 1. Identify the dropdown element. First, you need to locate the dropdown using any suitable locator strategy, like ID or XPath. Example, Java code. Webelement country dropdown, driver, find element. By id, country. 2. Create a select object. Once you have the webelement, create a select object for it. Example, Java code. Select, new, select, country dropdown. Now, you can use this object to perform selection operations. 3. Select an option. There are 3 ways to select an option from the dropdown. By visible text. Example, Java code. Select by visitext. By index, 0-based. Example, Java code. Select by index. By value, from the HTML value attribute. Example, Java code. Select by value. The most common and readable method is select by visitext, especially for user-facing options. Deselecting options, only for multi-select dropdowns. If the drop-down allows multiple selections, you can also deselect items using example, Java code. Select, deselect, index, 1. Select, deselect, biselect, bisiva text, Canada. Select, deselect all. Note, these methods only work when the tag has the multiple attribute. 5. Check if drop-down supports multiple selections. You can verify if a drop-down allows multiple selections. Example, Java code. Boolean is multiple. Select is multiple. 6. Get all options from the drop-down. You can fetch all the options to validate or iterate. Example, Java code. List all options, you can select. 4. Web element option, all options. System.out, println, option, getX. To summarize, when working with a standard HTML dropdown, use the Select class in Selenium. Choose the method that best fits your test case by text, index, or value. And always check if the dropdown is multi-select if your script involves deselection. Handling dropdowns is easy once you master the Select class, but always inspect the HTML carefully, because custom-styled dropdowns may need different handling techniques, using clicks or JavaScript. During web automation testing, it's common to encounter JavaScript alerts, those small pop-up dialogues that appear in the browser to show messages, confirm actions, or ask for input. These alerts are browser native, meaning they're not part of the HTML DOM, so you cannot locate them using normal locators like XPath or CSS. Instead, Selenium provides a built-in interface called Alert to interact with these pop-ups. Let's break down how to handle different types of alerts using Selenium WebDriver. 1-2. Accept the alert, click OK. Switch to the alert window. First, you must switch the driver's context to the alert using example Java code alert, driver, switch to alert. This gives you control over the alert box. 2. Accept the alert, click OK. Example, Java code alert.accept. This is used for simple alerts or confirmation boxes where you want to click the OK button. 3. Dismiss the alert, click cancel. Example, Java code alert dismiss. Use this when you want to cancel a confirmation pop-up. 4. Read text from the alert. Example, Java code string alert text alert.getX. System.out, println, alert messages, alert texts. This is helpful for verification, like asserting the alert message in a test case. 5. Enter text into a prompt alert. Example, Java code alert test input. Only use this if the alert is a prompt box that allows user input. 6. Common use cases you might automate. A form submission that triggers a success or error alert. Deleting a record that asks for confirmation. Login flows that show invalid credential pop-ups. Prompt alerts asking for verification codes or inputs. 7. Handling alert exceptions. Always use try-catch blocks or wait conditions to avoid no alert present exception, especially when alerts may appear conditionally. Example, Java code try alert driver switch to alert.accept. Catch knowledge present exception raw. System.out println. To summarize, Selenium's alert interface allows you to accept, dismiss, read, or send text to JavaScript alerts. You must first switch to the alert using driver alert, because these are not typical web elements. Handling alerts gracefully ensures your automation script is stable and doesn't break due to unexpected pop-ups. In modern web applications, it's very common for links or buttons to open new windows or browser tabs. For example, a login page might open a Terms and Conditions link in a separate tab, or a file download might launch in a new window. When this happens, Selenium stays focused on the original parent window, and we need to manually switch the control to the new window if we want to interact with it. Let's walk through how Selenium handles multiple windows using window handles. 1. Get the current window handle. Every browser window or tab has a unique ID called a window handle. We start by storing the current one, often referred to as the parent window. Example, Java code. String parent window, driver.get window handle. 2. Perform the action that opens a new window. For example, clicking a link that opens a pop-up or a new tab. Example, Java code. Driver find element by linked text open help. Click. 3. Get all open window handles. After the new window opens, use this to fetch all handles. Example, Java code. Say, all windows, driver, get window handles. This returns a set of unique IDs for all open windows or tabs. 4. Switch to the new window. Loop through the set of window handles and switch to the one that is not equal to the parent. Example, Java code. 4. String window, all windows. If window that equals driver window break nail. Now, Selenium will control the new window and you can interact with its elements. 5. Perform actions in the new window. 1. You can now locate elements, fill forms, click buttons, just like in the main window. 6. Close the new window and return to parent. Once you're done, you may want to close the pop-up and go back. Example, Java code. Driver close closes the current window. Driver switch to window, parent window. This ensures your script doesn't break when moving back to the main page. 7. Handling more than 2 windows. If your test involves 3 or more windows or tabs, store each window handle in a list or array and switch based on index or window title. Example, Java code. List windows, array list. Driver get window handles. Driver toy. Windows get 2, switch to third tab. 8. Bonus. Switching by window title, kind. Sometimes it's useful to switch based on the page title. Example, Java code. 4. String window, driver, get window handles. Driver, switch to window. If driver, get idle. Contains help page. Break. 1. To summarize, use get window handle to track the original window and get window handles to retrieve all open tabs. Loop through them and use switch to window to move between them. Mastering this flow is crucial for handling pop-ups, downloads, external pages, and multi-tab workflows in test automation. When automating web applications, sometimes basic element clicks aren't enough. You might need to perform advanced user interactions like hovering over menus, drag and drop, right-clicking, or keyboard key combinations. To simulate these real user behaviors, Selenium provides a powerful tool called the Actions class, part of the org OpenKey.Selenium Interactions package, This class enables us to build and perform complex mouse and keyboard actions using a chain of commands. Let's look at the most commonly used actions. 1. Mouse, hover, move to element. Useful for opening drop-down menus or tooltips that appear on hover. Example, Java code. Actions, new actions, driver. Actions, move a tool element, driver find element, by, aid menu. Perform. The perform method executes the built sequence. 2. Click, double-click, and right-click, context click. You can simulate single, double, or right mouse clicks. Example Java code. A. Actions, click. Perform, left click. Actions, double click. Perform, double click on element. Actions, context click. Perform, right click. 3. Drag and drop, Y. To move an element from one location to another. Example, Java code. Web element source UK driver find element by id source. Web element target to driver find element by id target. Actions, drag and drop, source target. Perform. Alternatively, you can use click and hold with release for more control. 4. Click and hold release. Good for sliders or complex drag scenarios. Example, Java code. Actions, click and hold. Move a tool limit. Release. Perform. 5. Sending keyboard keys. You can simulate typing, special keys like Enter, Tab, Shift, etc. way. Example, Java code. Actions 10 keys, Enter. Perform, press Enter. Actions, send keys, element, user nama123, .twa. Perform, type in an input field. For combined keys, like Ctrl-A or Shift-O-click, you can chain them. Example, Java code. Actions, key down. Send keys. Key up, keys, control. Perform. 6. Keyboard navigation in forms or tables. Useful for tabbing between fields or using arrow keys to navigate. Example, Java code. Actions, send keys, tab. Send keys, next field. Perform. Actions, tend keys, arrow down. Perform. 7. Build and perform. The build method can be used to compile multiple actions before executing them together. Example, Java code. Actions, move a tool element. Click. Build. Perform. 8. When to use the actions class. Hover-based menus. Custom sliders. Drag and drop components. Simulating real user keyboard shortcuts. Right-click or context menu interactions. If the default click or send keys doesn't work, especially for dynamic elements, the actions class is often the solution. To summarize, the actions class in Selenium allows you to simulate advanced user behaviors using mouse and keyboard. You can chain multiple actions like hover, drag and drop, and key combinations, and then execute them with perform. It's a must-have tool for interacting with complex UI components that don't respond to simple clicks or inputs. Thank you so much for watching this video on Selenium interview questions. We hope it added value to your preparation and boosted your confidence for upcoming interviews. If you found the content helpful, please give it a like, share it with your friends, and don't forget to subscribe to the channel for more testing tutorials, real-world automation examples, and detailed interview guide. Drop your questions or suggestions in the comments. We'd love to hear from you. See you in the next part. Happy learning, and all the best for your interviews.